Hello and welcome to this INSEAD webinar on AI's untapped business potential. My name is Katie Scott, and I'm a senior editor at INSEAD Knowledge. Today, I'm joined by tech entrepreneur and executive Yann Lechelle and INSEAD professor Theos Evgeniou. All right, I'd like to welcome Theos Evgeniou. He is a professor of technology and business at INSEAD and a director of multiple executive education programs on AI, both for companies and open enrollment, including the ever-popular course AI for Business. Welcome, Theos.
Thank you, Katie. Looking forward to the webinar.
And Theos will be talking to Yann Lechelle, who is currently CEO of Probable, which he will talk about later. And he was recently awarded the French National Order of Merit, which is one of France's highest honors. Here you can see him receiving it, thanks to his work and his conviction to make sure that Europe is not left behind on AI. Welcome and congratulations, Yann. Yann, could you tell us a little bit about your journey from INSEAD to becoming a knight?
Thank you, Cathy. A pleasure to be here and super happy to see some familiar faces in the audience. And I saw Benjamin and Antoine, Constance, Edouard. So yes, INSEAD, 2001. That was a quarter of a century ago. And just after INSEAD, actually, I became an entrepreneur. At the time, I was quite lonely because the French tech ecosystem was not quite formed. And it has taken a good 2 decades to get to where it is, not without difficulties. It's been a slow start, but we can say today that the French tech ecosystem in Paris, not dissimilar to Berlin, actually, and a little bit behind London, is quite formed. And so, just after INSEAD, in fact, through the entrepreneurship electives, I decided to build my own venture. So I was part of the new ventures class. And that led to my first venture, and then my second, and my third, and my fourth, and my fifth, and my sixth. So I've been a repeat entrepreneur, exiting every single one of my startups, but not by choice. In other words, I had to sell the companies because they had reached a critical mass or plateau. And in some cases, I was facing bankruptcy. So I had to sell the companies. And the problem here in France or in Europe in general is that we do not have an easy exit market, contrary to the US. And that has led me to actually realize that we are still immature as an ecosystem. So every next experience was bigger and more ambitious, but still lagging behind in terms of creating the impact that I wish for Europe at large. More recently, I was CEO at Scaleway, which is a cloud operator. So that was actually my first job post-INSEAD as an executive, as part of an existing venture. Scaleway belongs to the Iliad group. It's one of the top 3 cloud providers in France or even in Europe. But that job actually was a lot about change management, but also trying to catch up with big tech, namely AWS, GCP, and Microsoft Azure. So I developed and hyperscaled this company for 3 years, up until now, where I started again a new venture in AI. Now, this arc since INSEAD has been about managing innovation, has been about also facing the demand side, which is about adopting innovation. So we'll talk about that, of course, in the case of AI. My interpretation of why I was knighted is because I've been relentless. I've been dedicated to building technology and bringing the ecosystem together so that we actually go through the steps to become the ecosystem that we can be and that we should be. So I suppose that people high up in the government identified that approach, my persistence, I suppose, and that led me to be named into the order, which was specifically actually at the time where I was CEO at Scaleway. But that bleeds over to my current mission. And I suppose we'll elaborate a little bit on that a bit later.
Wonderful, Yann. What would the world be without people who persist for missions? Probably not as exciting. So thanks for doing this, and congratulations for the award, which is of course well deserved, and more to come, I'm sure, and more value to be created. Wonderful journey, and looking forward to also now discussing with you. There is a lot around the good fight that you've been putting in some ways. We'll come back to this later in the discussion about what's the, in quote unquote, fight, if I may use that term, or at least the mission, is probably a better term, especially given the context of where the world is today, both geopolitically, but also technologically and scientifically, which is very exciting and sometimes potentially scary also. So looking forward to this. So we can start, feel free to start from wherever you like. The floor is, guide us on this. Thanks a lot for this. But I can start quickly before that on some background knowledge about AI for us to set the stage. We'll talk about the part of AI which is potentially a bit forgotten, because we're all extremely excited by the latest generative AI, the latest large language model or video or image or speech or whatever. But we forget the more, let's say, by now called traditional, I've heard it's called vintage sometimes, which is a very funny name, or let's call it predictive AI. So let me briefly set the stage about what are the different types of AI. First of all, I'd like to say that the word AI as a name has been 70 years around or so, but the concepts and the principles have been actually used in business for centuries. And I think it's important to realize this. Let me give you an example. Let's think about one version of AI where you have like a black box that does things. In this black box, you put in some information, for example, your age, your income, your previous loans or whatever, and how much you would like to get as a loan. I'm thinking about an example of a credit approval. This black box takes your data points as input and gives you an answer. Here's your loan, or you're not approved, following certain rules, which may be explicitly written. Now, this black box may be a human brain that reads a bunch of rules written on a piece of paper, which is how AI used to run for centuries in banks. People were following rules written on a piece of paper already from the 15th century, if not before. So in that sense, AI existed there, but the black box was really a human reading the rules. Now, if we take those rules and we put them on a server, and instead of having a human just reading them and applying them to the input data, then we call it AI, but the idea is the same. It's just a digital version of applying the rules. So this is kind of expert system rule-based AI, where the rules are written by a human expert. And they have been around for centuries in business. We just didn't call it AI. The difference from the modern versions of AI, if I may say, although this one I just described already is very widespread and very used, and lots of startups, so-called AI startups, even in Silicon Valley, are using this kind of AI for many things, rule-based AI. So you should not shy away from that. And it's relatively easier to build because you have less data-heavy kind of infrastructure and more like you think about the rules of your business decisions. But the difference from modern type AI is that the rules, instead of being written by a human expert who developed those rules based on their experience, and if you think about this, experience for a human is previous data, previous applicants, previous customers, previous patients, or whatever. You put in all this previous data in another black box, which is called a machine learning algorithm. It can be a regression for simple things, or all the way a linear regression, or something as complex as deep learning, which we can touch upon, and we all know about recently being used. And then that first black box, which is an algorithm, machine learning algorithm, analyze the data and identify what are the best rules to then use to make decisions going forward. So the difference is, instead of having one black box, which used to be a human and now it's a server that applies the rules, you have two black boxes. The first one takes the data, finds the rules, puts them in the second one, and then we use them. Now, depending on what this is used for example, if this is used for simple, in quote simple, let's say prediction of whether somebody will default or not, whether somebody will buy a product, whether somebody will leave from a company, or whether somebody will join a company, or whatever, all those kind of outputs where you predict a specific simple decision, let's say simple prediction. When we have simple predictions or relatively simple, we call this predictive AI. So when the output is relatively simple, we call it predictive AI. And when we have complex predictions. For example, the output may be the prediction about how the DNA or the protein structure may look like, which is a graph in some ways, in some complex graph, or it can be text, or it can be an image, which has a specific structure. When the output is very complex, and it looks like it's the second box, the AI box, is generating something like a text or an image, we call it generative AI. If you talk to computer scientists, both of them, at the end of the day, are input is something like a prompt or the data of an applicant. Output is something like prediction whether the applicant will default, or a whole page of text. In both cases, input is numbers, output is numbers. They are all the same, and they all rely on this magical equation that an algorithm called machine learning has identified from previous data. However, for practical purposes, we call it one generative AI because it generates lots of complex output, and the other predictive. Lots of the focus today is on the generative AI. And also, just to add here, in general, instead of learning rules, which are relatively simple, we can learn complex equations, generalizations of rules, let's say. For example, some large language models have billions of equations. So when you hear Llama 7B, it means 7 billion equations. When you hear Llama 400B, it's 400 billion parameter equation. It's an equation with 400 billion parameters, right? So it's very complex. But having said this, because generative AI became so much friendly, and we'll talk about this in a few minutes, there is a lot of focus these days on generative AI and quite less attention on the predictive AI, which, as we'll discuss with Yann, can create enormous value. So old-fashioned AI that was not called AI, rules written by people, rule-based AI on a server, machine learning-based predictive AI where the rules or the function are found by data, by machine learning algorithm, and then used to predict a simple output, and generative AI when the output is so complex that it becomes text or images or video. This is roughly the categories in some sense.
Thank you, Theos, for breaking down those differences. Yann, I'm going to turn to you now to build on what Theos was saying. Why is there such hype around generative AI, and is it justified?
Thanks. I think the question is key because we need to unpack the hype. We need to see as decision makers, where do we invest our time and energy? So while we're talking about AI, the one big elephant in the room is data. In other words, where does the data come from to build generative AI models for once, but also what data do we feed into it to leverage models and generative AI or predictive AI? That is a universal question. Now, before we dive into that, what I find relevant is to find analogies. Some of us in the room are old enough to remember when the internet became a thing. So late 90s, there was a sort of tipping point where individuals could suddenly embrace the internet. Now, the internet had been invented many decades before, and the World Wide Web was invented in the early 90s. But at some point, every single individual was able to buy a personal computer, buy a modem, and connect to the internet. At some point, companies had to decide whether they would embrace the internet. And some companies actually blocked off the internet. Employees were not allowed to use the internet at all in the office, which created a huge frustration, made absolutely no sense. And the IT department was basically saying, no, it's too risky, and we don't need it, and so on and so forth, finding all sorts of excuses. Fast forward 2 decades, of course, that's not a question anymore. So now, GenAI. What happens with GenAI is that it comes from consumers. Everyone was able to attest that ChatGPT was actually quite amazing. And very quickly, within 2 years, so the cycles accelerate, right? While it took maybe 10 years for the World Wide Web to be fleshed out and became a possibility for startups and new ventures, in terms of the paper in 2018, I think there was, right? 2018 was the paper written by researchers at Google. All you need is attention. That paper, within 2 years, generated ChatGPT to some degree. Interesting to see that it's not Google that created ChatGPT, but then ChatGPT was available to everyone, and it's probably the most adopted technology by humanity in the shortest period of time at the time. And so that created a sort of shock. Individuals realized that this was new potential, new opportunities and therefore also new risks. The entire industry has been reconfigured because of that shock. And now we are 2 to 4 years after that. The amount of capital that's been invested, in fact, some people say incinerated. There's an article by a partner at Sequoia that says that $600 billion of capital have been incinerated. Again, not dissimilar to what sort of money was invested in telecom industry, 3G, exactly just after I graduated in early 2000. So it's interesting that the B2C creates a pull for a new type of technology, a paradigm shift in some ways. And then the entire industry has to decide to adopt it or not. But more or less, if you don't adopt it, go back to the internet, you'll be lagging behind. So to me, the hype is about perception, usually from B2C, and at some point, business processes have to adopt it. Now, that is where I think we should try and focus on in the conclusion today. How do we embrace that disruptive technology of sorts so that we are not left behind as decision makers, as people responsible for P&L, and where does it impact the top line, the bottom line, and so on and so forth, without falling into the trap of incinerating capital if we don't have any. In other words, where do we put the cursor? And is it really about generative AI? Or is it about leveraging data to the fullest extent, using all sorts of machine learning, including, of course, GenAI? So to me, that is the conundrum. That is, of course, a moment in time where GenAI is actually very promising. You know, smart VCs are putting their money on this. And but of course, there's a bubble of sorts as well. So calibration, unpacking what it means, but also really looking at the fundamentals.
So absolutely. Just to add a few things here. First of all, it's all about using some new technology, call it whatever you like, to create value and have impact in new ways that we could not do before. And that's the exciting part. And the question is, what can we do now that we could not do before? And what value will this create? Business value, economic value, social value, whatever value, right? And that's the main question we should all ask. And I fully agree, and I'd like to emphasize here what, Yann, you said, which is, another way to say this is that, yes, there is hype, but there is also really a new world. There is new opportunities. And the biggest risk that businesses face today is not to have AI fast enough and effectively enough. That's by far the biggest risk. And especially given, as we come back to this, on difference between different regions. I'll add one more thing here, maybe a bit philosophical, maybe it's scientific, I'm not sure. But somehow, to me, generative AI is very much a microscope to human nature in some sense. And there is a lot of ways to unpack this sentence, including how we can see language being, algebra, and how we understand the meaning of words in different ways using, mathematics in some sense. But it's also a microscope in the following sense. People love to speak to other beings who speak like people. So until now, AI was spitting out numbers, predictions of some sort. Now AI is spitting out language. It starts feeling like it's like us, right? So this kind of homophily, in a sense, makes us comfortable, and suddenly everybody can talk to AI. Everybody can interact with AI. It's very easy because it's just speaking to it. And that's because, we like homophily and we like to talk to other species that behave like us. And that was part of the reason why we are so excited, and why it's also kind of GenAI democratized AI by making it easy. We can speak to this, and also there's an emotional aspect to it, maybe an instinctive aspect to it, that it's very easy to use this. This also enables new possibilities that we can come to. There was an article at HBR just yesterday or 2 days ago making a whole list of new applications of GenAI. Some of them are very interesting, goes back to, it says more about humans than about AI probably. Things like the number one usage from B2C, as you said, Yann, is using GenAI as a therapist, or as finding the meaning of life or something, or your purpose in life. I'll put this on the chat, a link with all sorts of applications, which says a lot more about people than about AI, I believe. But the point is here, there is new ways to use this technology that actually, maybe it is a better therapist. And in fact, there is already some research, a month old or something, that shows that indeed the effects of using some types of generative AI as a therapist actually work better than, or as well, at least some human therapists. So this shows a lot about we are at the beginning of a major transition. I dare to say in human history, literally, because we have something with us that we didn't have before, which has increasingly powerful capabilities and therefore enables new value creation and new changes in the world. So Yann, floor to you.
Yeah, so typically it starts there. In fact, I mean, some of us who are deep in the field, in fact, I'll talk about probable at some point, but probable is a lot about AI for math people, whereas generative AI is a lot about AI for literature people. In other words, it's all about language processing. And even though we are working in the field, working with actual use cases in the industry and so forth and so on, most of the use cases, as Theos mentioned, are NLP, natural language processing. In other words, it's helping translate, it's helping organize knowledge base that actually turn into chatbots. By the way, chatbots, we've been promised efficient chatbots for the past decade or plus. Finally, chatbots will be able to converse intelligibly, right? So the promise of chatbots is now being answered through and thanks to generative AI. All of that is based on, FAQs, databases of knowledge. And these things actually have been around forever. The data was ready, but the interface was not ready. So the number one use case is a human-machine interaction layer. And that is by far the number one interface. Some of it is reflective, as you said, Theos, right? Acts as a therapist, because it allows you to confront your ideas with an established corpus. So that interface is the natural use case. The second use case is when you use that interface to bind it with business processes. Now, that becomes very powerful because in the past, we had to build graphical user interfaces that are complex, but they're also very constrained. So the advantage of a graphical user interface is that it is extremely well formed. So the process, the business process is engraved in the user interface. So people cannot stray too far from the interface by design. So think of it as, very structured engineering. Now, natural language processing is very soft. So, I mean, some of us here at INSEAD, you've got the hard skills people and the soft skills people, two different categories, right? So GenAI is really very much on that second bit. And finally, the question is, once you connect to business processes, how do we blend everything with fraud detection, querying analytics as a decision maker? Do you have to go through an interface, or can you form a query in a way that is both handled through a natural language interface, but also querying analytics that are very deep inside? So to me, the use cases are really, really wide and far, but starting from the human interface. And then, of course, the real opportunity is what you can do by connecting that interface layer to the bottom of the stack.
Exactly. So it's fascinating. The biggest change, as I said, the biggest challenge in technology adoption is change of human behavior. So the easier you make it for humans to interact with the new technology, the better. So in this case, we have an amazing natural way to interact with technology, which is, language, very human friendly. So this enables kind of easier adoption in some sense, and also why it's so fast that's adopted. One more thing you mentioned about how many FAQs and kind of the data being there for some time, but we didn't have a friendly way, a human-friendly way to access it. You remember probably when you graduated, I think it's around there, there was this new wave at the time, called knowledge management, 2000, 2004, something like this. Everybody was talking about knowledge management. It was a big hype in tech at the time, which didn't go that far. I think it did something, but not as far. So now with this kind of interface, effectively we're revisiting knowledge management, but probably in a much better way. So in a sense, knowledge management 20 years ago was maybe 20 years ahead of its time. So now
Yes.
we have this in some ways.
But rebounding on this particular point, what's interesting with knowledge management is that a long time ago, we had very structured knowledge. So it was bottom up. We create the knowledge structure and all that. Then knowledge management tried to introduce top-down. In other words, how do we leverage unstructured data, let's say chats in a enterprise setting? How do we organize documents that are unstructured into a knowledge management base? How do we extract knowledge from these things? So what's interesting is that natural language processing, or the category of large language models and generative AI, can massively improve the processing of unstructured human-produced data. That is actually the novelty here.
Thank you both for that really great description of GenAI and what we can use it for. But let's get back to predictive AI, which is where we've sold the untapped business potential. Theos, do you want to kick us off with telling us a bit of the history behind predictive AI?
Absolutely. Thank you, Katie. So first of all, the history of predictive AI and in general AI, it's fascinating. And it says a lot about the sociology of science, different communities moving in and out. For example, AI, the machine learning breakthroughs of AI came not from computer science, but from mathematicians and statisticians and even some physicists. So the sociology of science and research is very, very important to understand the history of research and science, and also to understand the future of it. Where will it go now? So currently, for example, lots of the AI work is dominated by engineers. But maybe history tells us that the breakthrough will come from somewhere else. We don't know, but just who knows what it is. So again, it's important to realize that the name AI is new, but frankly, it's like I'm not sure who cares about the name in some sense. The idea that a box will be taking input some data and doing something outside has been around for some time. For example, think about autopilots in the planes. The first autopilot was sometime at the beginning of the 20th century. So that was based a lot on what used to be called control theory. And control theory was very much behind the Second World War kind of engineering, if you like, military technology, and was going all the way up to the 1980s or something. Control theory was one of the main fields, if you like, to control, if you like, machinery with intelligence. At the end of the day, you're trying to control the behavior of something. For example, a robot. Back then, it was not a robot, but it's an airplane that does things, takes us input the signals from the wind or whatever, the speed, and adjust the the wings or everything else, 1,000 adjustments. So the whole history of AI is continuous all the way back to potentially, one can go arguably, to centuries BC. I just put on chat for everybody a small history of brief history of AI I wrote about a year ago. It's really one of my favorite pieces I've ever written in my life, so I just share this emotionally here. So I highly encourage you to go through this. It has like so many links, you can spend a lifetime in there. It starts from 600 BC, actually, because it talks about basically the move between, and this is very important, the move between mysticism, what people today call I'm making a business decision based on my gut feel, that's mysticism, towards empiricism, which is I'm going to make a business decision based on data and evidence. Whether I analyze the data and make a decision, or whether AI analyzes the data and makes decisions, it doesn't matter. The point is it's based on evidence and data. And that's a fundamental change. And by the way, I usually ask executives, where are you today? How many of you are still mysticists in the pre-600 BC era? And how many of you are, in the 21st century? And of course, usually the answer is most of us are still in the pre-600 BC era. And that's very important to realize, because it's about data-driven decision-making, which is something humans can do by themselves, and AI does by definition. So that's a little bit broadly the history. And again, the article I put on the chat has a lot in there. It's a lot of fun for those of you who like history a bit, and you can see also the sociology of research and where we are now. Just to give an example, where we are now in AI was also impacted by the collapse of the Soviet Union, believe it or not, and the fall of the Berlin Wall. Lots of this in that article, you will see how that worked. And interestingly, again, all this progress led to GenAI, but until GenAI became so popular because of the English language, as we just discussed, and the new applications, most of the applications were on predictive AI. In fact, the first, one of the early studies on the impact of AI on the economic impact of AI, which was from McKinsey 3 years ago, 2-3 years ago, they estimated, it's a rough estimate, of course, we can criticize this, but just to give a sense, the estimate at the time was there will be, let's say, $20 trillion of new economic value created by AI in the coming 10 years or so. Out of the 20 trillion, 7 were coming from GenAI, in line with the Goldman Sachs report I put on the chat, actually, and 13 from predictive AI. Now, of course, as we'll discuss later with Yann, predictive and GenAI are mixing, and we'll come to this in a second. But the point here is that still most of the business value seems to be coming from predictive AI, which is something that we forgot within the hype and excitement about being able to speak in English to an alien species, which is called AI. But the value is from predictive, and we have to focus on that. And Yann, I'm sure this relates very much to probable. So happy to hear what you are doing in probable and how you see the value from predictive AI in business and what you are creating.
Okay, great. So I'll just share a link here because I'm going to use a term that's really, really hard. I mean, the people who actually created this amazing piece of technology are not really, really into marketing, at least at first. So the name is impossible. I'm going to talk about scikit-learn. So here's the link for those who are interested. So it turns out that 2 years ago, a team of researchers.
Yeah, I interrupt you here just to note, this is something that I've been using and saying for many, many years. I didn't realize you are behind this. So very happy to see the team who is behind this thing. This is huge. Just
So to be clear, I am not behind this. I am just an entrepreneur and a business person,
yes.
Right? I did not write this piece of technology. I have no merit. The genius behind this is a team of researchers at the INRIA research lab in France. And this has been incubated there for about 10 plus years. Now, what's interesting is that what we know of as the data science practice, that could be in a research lab or that could be in a company setting, data science as a practice has been growing since the advent of big data, right? So for the past decade or a little more, we've heard the term big data, data science, data mining, so on and so forth. Now, this practice, we could say that has been stimulated or probably accompanied or even possibly co-created with that tool called scikit-learn. Scikit-learn is a piece of technology that is applied math specifically for the type of machine learning that is not deep learning. Although, to be fair, scikit-learn does deep learning as well. But for deep learning, you probably use different tools today, like PyTorch from Meta or TensorFlow from Google. But it turns out that scikit-learn is a hidden treasure. In a way, it belongs to humanity already. It's a public good. It's been downloaded 2.5 billion times, 90 million times per month, 22% from the US, 25% from China, 14% from India, 3% from France. I mean, here is an asset that is open source, free to use, enabling the entire practice of data science for the past decades. And in fact, scikit-learn generates more downloads than PyTorch and TensorFlow combined, which means that, of course, the hype is all around deep learning and GenAI, but even that hype is as much, if not less, than the legacy for machine learning or traditional machine learning applied to tabular data. Tabular data is basically quantitative data, or if you wish, data that fits in a large Excel file, right? Typically, GenAI handles unstructured text or images that do not fit traditionally in an Excel file. So the part that I'm focusing on is scikit-learn, which is an asset that was spun off from the research center. So I'm responsible for the spin-off. And of course, I've created a business model around all of it. The model that we borrow from in terms of the philosophy is Red Hat. Red Hat is to Linux what probable is to scikit-learn. That's the easiest way we found to make the analogy. Now, going back to predictive AI, scikit-learn is a tool that allows predictive AI. And you all know the use cases. In fact, they're all around us. Scikit-learn typically is used to create models that detect fraud. So banks and insurance companies, they leverage scikit-learn to analyze patterns in transactions to infer whether the transaction is a fraud or if it's at risk or atypical, so that you can flag it in some ways. It's used in finance in general for anything that is predictive, right? So you find it in time series, you find it in portfolio management, and so on and so forth. You find it in logistics to detect faults in a pipeline or in a supply chain. You use it in e-commerce to do recommendation. So typically, scikit-learn was all the rage at the time where Amazon was providing more recommendations, or Netflix providing the next recommended movie for you, tailored to your own taste. So predictive AI is all around us, has been used also because it is understood. We talked about GenAI. GenAI is a bit of a black box. That's why companies are focusing on trying to pry it open. How do we pry it open so that we can guardrail it? How can we ensure that the data that is output from a GenAI pipeline is sure or 99% sure, or is it constrained to the biases that we want it to have instead of the biases that we don't want? We also have these problems in predictive AI. However, they are a lot more mastered and understood. So, and also it works on frugal, smaller data sets. So it's part of the bigger family, but predictive AI has been around for longer. You have teams that are familiar with it, but most importantly, it's all about the data. How do you actually unravel the data? How do you produce the data? Could be actual data or synthetic data. How do you augment the data so that your predictive AI allows you to make the next predictive decision, business decision? Generative AI, as I said, is very good for the interface layer. So again, predictive AI has been around for centuries, as you say, Theos. Technically has been quite accessible for the past decade. In fact, data scientist was coined as the sexiest job in the world in 2012 and was again confirmed as the sexiest job in the world in 2022. So it's interesting because data scientists keep getting hired. So the US US Bureau of Labor is forecasting, probably using predictive AI, growth for the industry and for the job category, double-digit per year for the next decade. And this will increase and accelerate because of GenAI and because companies now are looking at AI because their board is telling them to, because the market is telling them to, not because GenAI is the answer, but because we need to leverage the potential of data in the greater category of AI to make better business decisions. And I like how you framed it, Theos. Go from esoteric or yes, to actually, since we do need to decide in a group, in a consensus way, through a board decision or through a collective, then we need to show the data, show the proof. And that is how we make decisions today, because that is actually more solid in a market that is actually too complex to handle for human beings. Intuitions are becoming a liability in some ways.
Great. I'm going to jump to an audience question now. We have one from Amir. As organizations are starting to move from capital allocation for AI initiatives to actual deployment, how can we shift the conversation toward managing scale and cost efficiency in AI LLM usage so that we clearly understand the operational and financial implications of scaling these technologies across the enterprise? Very long question. Theos, do you want to maybe start with an answer?
Then, Yann, you can fill in, I'm sure, with a lot. A great question, by the way. It's all great until, it's all good, but it's in theory. You have to see it in practice what happens, right? So lots of aspects in this question. First of all, let me go a little bit back to the data scientist point that Yann made. I think at some point between 2012 and 2022, I guess, the most expensive resource to hire at some point became data engineers. Maybe it's now, I don't know who is now most expensive, data scientists or data engineers and AI engineers. But data engineers are, which also part of the answer to the question, were expensive because, as Yann said, first you have to make sure that the data pipelines, and what we call in an article we wrote in HBR a couple of years ago, the data supply chains you have, internal and external and across silos, are in place, and the data is flowing with good quality and the right time, right place, right usage. So that's part of the answer to your question. That's why data engineers became at some point also very expensive to find and very valuable. Having said this, to answer your question more broadly to begin with, the way at least one can structure the how do we leverage AI in the business can be as follows. First, start thinking about the capabilities of the organization, because you need to have in place some capabilities. Your data supply chains and pipelines and the data governance and quality and processes is part of the capabilities, right? How you gather it and you use it. Another part of the capabilities is the skills you have, and also where are those skills in the organization? How do you make sure that the right skill set is kind of creating an arc between the business need and the engineering on the other side? And how do you make this communication happening with the right organizational structure and the right teams and the right flow of knowledge and kind of sharing of expertise, including, for example, the new possibilities that generative AI allows to quickly create prototypes, at least to begin with, using even Copilot, for example. Then the other capabilities have to do, of course, with like the leadership understanding and kind of where is the executives, how does the executive team or the executive team in general understand what AI means for the business? I understand where the value chain AI can create most value, can be plugged in, understand what kind of changes in the way people work and also organizational changes in general are required to leverage this technology in order to adopt them. Remember, at the end of the day, people have to start using them. So there is always an avoidable change management component and the ability of an organization to change. And that's kind of the capability, if you like, the horizontal side. Then you have the vertical sides in some sense, which are the use cases. And Yann outlined a number of them. We talked about a number of them from predictive analytics. And you can take the whole, value chain, if you like, of the business and think about every place how to use data in order to improve decisions from the customer acquisition side all the way to product sales, pricing, recommendations, credit if you are in, or financial decisions if you are in the financial sector, predictive maintenance, or manufacturing optimization, you name it, right? So you have everywhere there is a decision to be made, and for which you have data, you can improve the decision or automate the decision in some sense. So that's like the vertical use cases. So the use cases with the capabilities, in a sense, are the AI strategy of the company. Where do we invest? That's, in a sense, if you want to simplify what's your AI strategy, okay, where do you put the money, right? That's your AI strategy, in some sense, capabilities and horizontal. And then on top of this, you have to wrap it all within an AI governance framework, which kind of takes into account, of course, anything that has to do not only with regulations, but also with business risks themselves because of AI. The reason you want to manage those risks is not just to be compliant, depending on which market you operate, but also because there is a business reason to have what one can call responsible AI, which we can come back later to unpack the governance side of AI. So that's a little bit the capabilities in place. And now, of course, going from a proof of concept to a scaled solution, that's another challenge. And the challenge there is both engineering, but also a change management challenge and also a regulatory challenge. You may end up in all sorts of kind of, privacy issues related that you run into or copyright issues you run into when you deploy at scale. So engineering people, regulatory roadblocks or challenges you may come across as you scale your proof of concept. I'll add one last point and pass the floor to you, Yann. The way to think, actually 2 quick points. The way to think about developing AI solutions is a little bit like developing drugs for pharmaceuticals. It's a bit like research. You don't know whether your data will give you what you want. So you have to put in place, you have to come in the game with a mind frame of like continuous experimentation, iterations, testing, kind of gated investment processes where you have to go through different loopholes in order to scale next. So that's one point. The risk profile of AI is R&D profile in some sense. And the other point, just to close there, is generative AI and predictive AI have slightly different ways of development and deployment. So generative AI starts from usually a foundation model, an LLM from Google or Mistral or whatever, and then you kind of put around this either a RAG, a database, retrieval augmented generation kind of database, or some fine tuning, or some prompts, system prompts, or whatever. Predictive AI, which is what we're discussing mostly in this webinar, starts from your own data. And the raw material is, that's where you start. You have nothing, you have no model. You have to start from your data. And that takes a lot more effort, of course, in some sense. And that's why it's also more challenging, but also more value creation as we discussed. Yann? maybe lots to
Yeah,
add over
just to
here.
wrap up on this question, because it's a deep question and it's also very specific and too specific in a way. I find that a lot of companies, as I said earlier, everyone is, attracted or forced to look into GenAI. So when the question is about LLM, I mean, that's not a question. LLM is just a feature. LLM is just a tiny bit in the conundrum. So experimentation, Theos mentioned it. We need to learn how to experiment. Actually, prototyping is something that needs to be accelerated at scale. You need to start experiments, kill them as soon as you hit a roadblock or a wall, mostly a wall. But most importantly, it's a strategy at the corporate level, because with generative AI on top of predictive AI, you've actually amplified the scope of data processing to the C-suite. It's no longer the chief data officer alone or the IT department to deal with these technologies. It's up to the CEO. In other words, the CEO cannot not think about where AI can play a role, because it will have a social impact in terms of the workforce, the societal impact in terms of the liability downstream. And in terms of the organization, it's all-encompassing, because if you want to leverage the unstructured data, potentially, you have to reach every corner of the company. And the question is, who has access to this power? Number one, as humans, but number two, as an AI. Can the AI be autonomous to reach out to all corners of the organization, or is it really siloed, and so on and so forth? So it's a C-suite, COMEX, or better yet, CEO level type of enablement, if you wish, so that you can maximize your adoption. But again, don't look at LLM. LLM is just a feature. I see it as a feature. But of course, it's an enabling feature, right? So I think we should, move into maybe how do we blend these type of approaches to maximize business potential.
That's exactly what I was going to ask you, Yann. Let's
Right.
look to the future. How can we fuse these two worlds of predictive and Gen AI?
Yeah, so quite concretely, because it's a tough, we talk abstractly. It's always important to go back to use cases, but let's go back to a simple use case where we have tabular data that provides a model that detects fraud. Now, the model will be as good as the data you feed it in. There's something called feature augmentation, right? The feature is a name for a column, right? So the column could be a timestamp, or could be the nature of the transaction or the amount of the transaction. But feature augmentation means that perhaps the data can be recalibrated automatically or augmented with additional features. These features could be linked, let's say you're doing a detection of incidents for an insurance company. Now, it's actually hard. Most of the time data scientists spend on is on massaging the data, doing data wrangling, augmenting the data manually, filling the gaps, making sure it's accurate or timely. Are we going to be able to plug it into sufficient amount of history and timeline, and so on and so forth? Now, GenAI can actually augment automatically the features, but also look up external data sources through all of this amount of information that LLMs have ingested. In fact, maybe that's a bit of a controversy, but LLMs have stolen all of the data available out there without asking the rightful owners of the data. So LLMs is a big fraud, but we get to use it. So if we use it, can we leverage an LLM, say, to infer from certain features the density of a city, whether there are a lot of schools, what's the average age of pedestrians, and so forth, so that you can augment your data and create a model that predicts incidents, accidents, in a way that is a lot more fine-tuned. Now, you use predictive AI on the data, but you use generative AI to generate additional features. So that's a simple example where the two really combine well together so that you have a better predictive model as the outcome. You can do it reversely. Imagine you have a predictive model that works quite well, but it is hard to operate using a graphical user interface, or you have to go through an Excel sheet that is overly complex. So as a decision maker, you don't have time. You need to make quick decisions, and decision makers make 20 decisions per day, some of them really, really important. So can we use user language, natural language processing, natural language to query a predictive model, right? So this is basically the augmented decision-making type of use case where, say, there's a predictive AI forecast for low sales, that is the outcome. The question is, can you leverage that, use generative AI to draft new marketing angles? Now, these angles, you could probably produce manually, but before you get there, you'd have to query the interface. Now, if you blend the two, the question is, the sales are down. What are the strategies? And the strategies come directly from the data that is generated by the predictive models, right? So that is exactly the way we need to think. We need to think holistically. And that's why CEOs need to think about this, because that can impact their top line or the bottom line, depending on what they do.
Lots in here. Let me add a couple of points here. You mentioned features, feature engineering, feature creation. At the end of the day, if we go back to predictive versus generative AI, if you think, and versus older, let's say, statistics, the classical statistics, which one may say what's the difference, the fundamental progress over the years has been from simple inputs in econometric models in the beginning of the 20th century, let's say, with very few variables, because we didn't have the compute power. People were doing this by hand, actually, back then, 1910, 1920, right? To more, even more features, some so-called high-dimensional input data. So instead of having 5 features, we have like 500 or 5,000 or 5 million. To complex features, for example, actual graph structures or actual text. Some of it may be automatic, some of it may be manually, which is called feature engineering. And that's where AI can help you actually come up with new features to put as input to your machine learning model. So AI is becoming a little bit of a data scientist, and I put 2 articles, one from the team of Yann and one from an article in Nature magazine a month or 2 ago, which basically shows how a GenAI is actually becoming a little bit like a data scientist that develops predictive AI models, because part of the data scientist's job and part of the business owner's job, business process owner's job, is to think based on the context, what features should we cook up that have a business meaning, that are informative, and that I can put in the model so that the model can become smarter. That's a question that humans used to answer, and data scientists and business people and analysts used to answer, or still answer, but now also AI can answer. And that's the merge of GenAI with predictive AI in some sense, where the GenAI is becoming the data scientist. You may have a data scientist soon in your fingertips. And I also put in and that takes us a little bit towards where we are today and where we may go towards, which part of the question you asked, Katie, which is we are observing the early signals, the early leaves, let's say green shoots, whatever it's called, of AI becoming a scientist, not just a data scientist that creates just new features, but a full-blown scientist who also comes up with hypotheses, and scientists in the sense of physicists, chemists, biologists. I put again in the chat a paper in some article from Google, but there's also an article in Nature magazine past few months. There is a work that we should watch on it, because that's the next big, huge thing in some sense, which is what happens when we build intelligence, intelligent enough AI that it can solve other difficult problems, like scientific problems, like finding new treatments. This a little bit summarized in the quote by Demis Hassabis that I love saying, which also relates to what both Demis and my PhD advisor, Tommy Poggio at MIT, happens to be his advisor, my advisor, has been saying for decades, which is the greatest of all great scientific problems is the problem of finding how intelligence works. And Demis says it, our mission at DeepMind is to solve intelligence and then use that to solve all other problems. For example, personalized treatment and personalized medicine, which is what he outlines in his Nobel Prize speech in last October when he got the Nobel Prize. So we're going towards AI becoming the scientist. Another area that we are seeing is the collaboration between humans and AI in new ways. For example, I saw a question by Fotis, with whom we are actually working on the use of AI in parliaments, in this case in the Greek parliament, but you can imagine generally. Think about how AI and generative AI can be leveraged to support debates, to support citizens' assembly, to support parliaments, both on the back office and during or after debates. This is something we are moving towards, and imagine what this means about both the discussions we're having in the organizations, but also the political processes we're going through, right, including parliaments. And there is a lot of opportunity there with huge consequences for society and for how we collectively make decisions, hopefully increasingly better with the support of our new, let's call them AI co-workers, for lack of a better word.
Great. I'm going to feed in one question from the audience. It's an anonymous person asking about the ethical concerns that are holding back innovation in AI. So Yann, how can these be addressed? How can businesses apply AI responsibly in untapped areas?
So GenAI is an order of magnitude more complicated in terms of ethics because it bundles a lot of human biases at scale, whereas predictive AI typically bundled biases for sure. Always, there's always biases. I mean, humans are biased by design, but typically traditional AI or machine learning is biased by virtue of the data set which you feed in. Now, LLMs are being fed a lot of data, but too much for human to comprehend, right? So at some point, people leverage the LLM, which is all packaged up and as a black box. And then without knowing it, they will unleash content or decisions that will be potentially ethically questionable. So we have to be double careful with this GenAI because it will produce results that feel like it's a huge saving of time, but it might be a huge liability in terms of ethical sense, but also straight up in terms of, you know, where this takes us collectively, right? Right now, the internet is a fake news machine. It's getting worse with generative AI, right? Because, of course, those who are willing to feed this fake news machine will leverage this because it's massively useful to propagate biases and manipulate information at scale. Now, usually democracies or straight up business people do not feed fake news because you get penalized heavily. But bad intent doesn't get penalized more heavily using one method or the other. So the danger on the ethical side is to actually harness the power of this thing, but technology is usually neutral. Biases are human, and they get amplified because humans actually select the data sets that go into these things. So again, GenAI is an amplifier. It's an order of magnitude more difficult. That is why you have companies that are created specifically to guardrail those models. We are going to need to massively surveil this new wave of AI and the future AIs all the way to AGI. That is a huge issue.
Yeah. So let me add here a few things. First of all, managing risks in general is necessary for business, for adoption of AI to begin with, and AI embedded products and services, but also by the employees, adoption of AI by employees. So it's a business reason to manage risks. Second of all, ethics is a difficult word because then the question is whose ethics and whose values. Third, remember, AI is making decisions. So by definition, we said this in different previous webinars, it exhibits values. It has values. I mean, it doesn't matter whether it has internally, but it behaves as if it has values. And finally, that to double down a little bit on what Yann said, I like a quote that goes along the line, whoever controls AI controls our ideology and therefore our future. Now, having said this, because AI is the new media, let's say, maybe we are facing the first kind of technology which is actually not neutral potentially. I'm just putting here a question mark because it behaves and it can influence the way we think. It's even a therapist to us, as we saw. So it has its own personality in a sense, as we know from our experience. So we may be facing something very new, which can have an impact on how we think. And that's something we have to really understand and manage.
Fabulous. Well, thank you both, Theos and Yann, today for your insights and expert opinions. I think we've all learned a lot. And for anyone interested, we have an upcoming AI forum. We have a whole lot more webinars on these topics and more. So please stay tuned. Thank you, Theos. Thank you, Yann.
Thank you, Katie. Thank you, Jan. Thank you, everybody.